So now we will learn how to perform a test or how to draw the dual slope characteristic step by step for one relay example, as you can see here. So the first step, you have to find out the general characteristic from the relay protection manual. So as you can see here, we can define the IDIF and the I bias characteristic by some parameter values like the IDIF minimum or IDIF greater. IDIF double greater represents the unrestrained differential function. We can define also the values and the graph in base point 1 and base point 2 to define the tripping zone and the blocking zone for the characteristic. So step 2, you have to define the number of lines in the characteristic from the relay protection manual. So for our example, we have a 4 line, line 1, line 2, line 3, and line 4. As you can see, line 2, the base point is the origin, and line 3 have another base point which called base point 2. The step number 3, how to find each line equation. So for the first line, which is the line 1, so this is the horizontal line, so the slope is equal to 0, and the IDIF can be represented by the IDIF greater or the IDIF minimum, as you can see. So the line 1 equation, IDIF equal to IDIF greater. The line 2 equation can be represented in that way. The IDIF equal to the slope 1 multiplied by between two brackets I bias minus the base point 1, and since the base point 1 is the origin and it's equal to 0, so the IDIF equal slope 1 multiplied by the I bias. Speaking about line 3 equation, which starting from the base point 2, so we can represent the IDIF equal to slope 2 multiplied by I bias minus the base point 2. And line 4 is the same as of line 1, but with a different value of IDIF, which equal to IDIF double greater. So the equation will be the IDIF equal to IDIF double greater with a slope equal to 0. So you can define the differential dual slope characteristic as shown in this photo between the IDIF and the I bias. But how if we need to make automatic testing approach and dedicated modules to test all this kind of differential characteristic instead of starting from scratch and draw it point by point and line by line, you can check our automated testing solutions using the OCC, which is the Omicron Control Center, which can be organized for a test sequence, and it's a container for a single test, so you can add many more test modules in the same file for find a customized test plan based on your protection application and protection function enabled or activated inside the protection relay. And at the end, you will find out the test result, which is written in the same and one combined test report for all function available inside the OCC. And the structure of the OCC, as you can see in our screen, it consists of the name of the OCC and then the test object, which represents the parameter setting of the protection relay. Then hardware configuration represents the analog output, current and voltage output from the CMC to the protection relay, and also the binary input of the CMC, which can get the feedback from the relay protection output. Then you can add one by one test modules to test all the activated and protection function enabled inside the protection relay, and at the end you will find one combined OCC test report for all this kind of protection function. But if you have any change in the test object or the hardware configuration, so the relation between the test object and the local test object, as you can see, so if you change any value in the general test object, it will affect the local test object. So once you are importing another relay parameter setting, it will be automatically change the values inside your customized test plan or inside your OCC file. So no need to start from scratch with a blank sheet of paper. You can importing exporting and importing the relay parameter setting inside the OCC, and it will be reflected and auto adjusted to the new parameter setting. And also, if you have any change in the global hardware configuration, it will affect the local hardware configuration. But this effect is only one way effect, because if you change any local hardware configuration, it will not affect the global one, as you can see from this relation. So here is the difference between the global and local hardware configuration and one directional effect. And on the other hand, the relation between the global and local test object parameters, which is a bidirectional effect. And here is the test object, which is a RIO relay interface by Omicron, which is a uniform data format for the protection parameter, and it's independent of the vendor. So this RIO is a characteristic information or a graph based or characteristic based. So there is no relay specific parameters, and this have some limitation of the RIO function, and there is no common file format such as XML or XRU, which we will see in the next slides. So we invented the extended RAU file, which a new technology, and it's used by many more manufacturers and many more competitor as well. So you can represent the parameter setting file based on the XRU format, which supports most of the protection relay types directly, sometimes as ABB and Siemens and SEL relays, and indirectly for other types using the general XRU converter. So here is the X-ray test object. As you can see, once you import the relay parameter setting for Siemens 7SA, for example, you will find all the parameter based setting inside the OCC test object, and you can change or modify any kind of parameter. And here is the link between the RAYO and XRAYO by using the XRAYO converter. So this is the protection or the parameter based, which have been imported using the X-ray filter. And also we have another feature which called link to X-ray, and this feature is very beneficial, especially if you have any update or any change in the protection relay parameter setting, because it will be automatically adapted to the new setting. And as you can see, you can link the injected values in the general module with the using the relay parameter setting by the link to X-ray technology, and no need to start from scratch or start with a blank sheet of paper. All the changed parameter setting will be automatically affected and adapted to the test points to easily used after that. And here's a summarization between the relation of RAYO, X-RAYO, and link to X-RAYO. And as you can see here, the RAYO characteristic shape can be represented by the distance module. As you can see here, the quadrature distance module, and also the relation between the RAYO and XRAYO. So once you import the relay parameter setting as a XRAYO file, there is a XRAYO converter, which is the link between the XRAYO and the RAYO file represented in the characteristic or graph shape. And also, if you are using a general test modules like the ramping module or the state sequencer module, you can use the link to XRAYO to automatically adapted if the relay parameter change it to a new values, so it can save your time and efforts. About the protection testing library, which is a free of charge and can be downloaded from our Omicron customer portal, we have more than 530 protection relay types available free of charge in our Omicron customer portal, and you are free to download any one or the complete package of our PTL, and to be used with the Test Universe software, to not start with a blank sheet of paper as you can see. So to meet all the change of the testing protection device, you can use our PTL or PTT available in our customer portal for many more relay manufacturers such as ABB, Arriva, SEL, Siemens, and many more vendors. And the benefits of the PTL, it will save your time. As you can see, it will save your work and your effort, because you will not start from scratch. You will find a ready-made customized test plan. You can add or remove any test module to be automatically adapted to your customized applications. And also you will use the relay parameter import using the X-ray filter or any other filter based on the relay type or the relay vendor, and it will give you a direct calculation of all the equations, like the differential equation and the REU files representing the characteristic of the differential function, for example, or the characteristic for the quadrature impedance characteristic. So it will saves your time by only by clicking import relay parameter setting, and it will give you also the know-how technology, and to get a source of all equation we use to build upon our BTL, so you can get the know-how in research purposes or learning purposes. And it's an open system, as you can see it. You can download and you can use it in any purposes like learning or testing purposes. And how we utilize the PTL templates. So first, the relay shall be configured by a well knowledge protection engineer. Then you can use the relay software to export the relay parameter setting. After that, you can import this relay parameter setting inside the OCC file using the dedicated filter, even if X-ray or direct filter like CSV for GE relays or SEL relays, and many more filters available inside our OCC. And then you can customize your own test plan, and you can do the commissioning and testing for using this OCC file. After that, you can hand it to the maintenance team, or you can distribute to your testing and commissioning team to use the same file for the same protection relay type, and it will be very easy and very fast, and it will save 80% of your time if you are using in the classical method or the manual method. And here is one slide which is important to know if you are using the PTL and the automatic testing approaches for Omicron, which is the tolerance levels. So, for example, we have a snapshot for the Siemens Protection Relay 7SCA tolerances, and this snapshot is getting from the relay manual. And as you can see, we have a different types of tolerance, or two types particularly of tolerance. One of them is absolute, and the other one is relative. So if you are manually testing or using the general test modules, you have to define which one it can be used to assess the test results. So normally, if we are using the automatic testing approach or using our PTL, it will define the whichever is greater. It will be the relay assessment for the protection results. But if you are modeling, and if you are built upon your customized test plan, and you are using a general test plan, general test modules like the ramping module or test sequence module, you have to define based on the setting whichever is greater, it is the absolute or the relative one, to can take it as a tolerance band for result assessment. Is it pass or fail based on the relay protection, the protection relay manual. So thank you everyone. This is the end of our theoretical presentation, and stay tuned for the second part of the demo and practical testing of the GE MICOM B643 relays 3-winding transformer differential protection testing using our new benchmark, the CMC 500, along with our powerful PC-based software test universe and the protection testing library. So thank you everyone. Looking forward to see you in the next part. Bye.